Okay, so I just decided I want to put together a video real quick of what happens when we have dependent events. Um, so a lot of times we've been doing independent, like roll and die. The first roll doesn't affect the second roll and so forth. But what if we do have events that are taking place where they do affect each other? So there are 5 yellow. Fix that right there. There are 5 yellow, 6 blue, and 4 red marbles in a hat. What's the probability of picking a blue marble, then another blue, and then a red without replacing any of them? Okay, so imagine you have your little hat or whatever bucket we're going to have. Okay, in that bucket, you have some yellow marbles. Get 5 of those, then we have some blue. 6 of those, and then we have some reds. Okay. Well, the first one's pretty easy. What's the probability I'm going to pick a blue on that first try? Well, there are 6 blues, and there were 15 total marbles. Well, I've now picked that blue. That blue is gone. So what's the probability that I'm going to pick another blue? Well, now there's only 5 of those left, but we also have to look at the fact that there was only 14 marbles now in there. And then a red marble. Well, there's still 4 red marbles in there because we haven't got any of them. And there are now only 13 left. So what you notice is normally picking a blue is 6 out of 15. A red is 4 out of 15, and yellow is 5 out of 15. But since these are dependent events, we're not putting them back. These probabilities change each time. Okay, so then we multiply these together. 6 over 15 times 5 over 14 times 4 over 13. That gives us 4 over 91, which is roughly 0.044. Now, MathXL will probably require the fraction, so you'd want to put the fraction there. This is very common with cards. Okay, if we had a card example, maybe they talk about picking a red card, then a spade, which is a black card. What's the probability that's going to happen? Well, probably I'm going to get a red card is 1/2. Well, and spade, well, that's a quarter of the deck. Well, the problem is we've already taken a card out of the deck. Okay, so there's still 13 spades, but there's only 51 cards. And that's 13 over 102. So when you ever hear about people playing blackjack and getting in trouble for counting cards, or just people being really good at cards, they have a good idea of how these events work. Like such as what's the probability of getting 2 aces? Well, the first card I have a 4 out of 52. And then the chance the next one is, well, there's only 3 aces left, but there's only 51 cards. And that's a 1 out of 221. So you have a 1 out of 221 chance that you end up with 2 aces in your hand when you're playing blackjack or any type of card game there.